In the last presentation, we completed decimal to octal conversion. The next conversion is decimal to hexadecimal. For decimal to hexadecimal conversion, we have to divide integer part by 16 and we have to multiply fractional part by 16 because 16 is the base in case of hexadecimal number system. The base or radix R in case of hexadecimal number system is 16. In this lecture, we will solve three problems. In first problem, I will not include the fraction. In second problem, I will include the fraction, and in third problem, we will include different base. So let's start with problem number 1. The decimal number is 254. This is in decimal, and we want hexadecimal equivalent of this number. So let's start with it. $254 is the decimal number, and we have to divide 254 by 16. We have to divide integer part by 16, and when we divide 254 by 16, the quotient is 15 and the remainder is 14, because when you multiply 16 by 15, the result is 240, and when you subtract 240 in 254, you will have 14 as remainder. We will again divide 15 by 16. The quotient is 0 and remainder is 15. Now if you remember the first presentation, we had 16 distinct digits in hexadecimal number system, starting from 0, 9, and 10 is written as A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So this 14 we have to write E, and this 15 we have to write F. This F is MSB, the most significant bit, and this E is LSB, the least significant bit. The most significant bit is the leftmost bit, so F is the leftmost bit, and the least significant bit is the rightmost bit, so E is the rightmost bit, and this is the hexadecimal equivalent of 254. Let's move to second example. The decimal number is 25.625. This is in decimal, and we want the hexadecimal equivalent of this decimal number. The integer part we have to divide by 16. $25 is the integer part, so we will divide 25 by 16. The quotient will be 1 and remainder will be 9. We again divide this 1 by 16. Quotient is 0 and remainder is 1. And we have to go from bottom to top. So MSB is 1 and LSB is 9. So 19 is the hexadecimal equivalent for 25. And now we will move to this fractional part. 0.625 we will multiply by 16, and the result is 10.000. And as I have already told you, 10 is written as A, so this 10 is A. We got A from this, and we are left with 0.00, and multiplying this by 16 will give us 0.00 again. So we will stop here, and the fractional part of this hexadecimal number is A. So 19.A is the hexadecimal equivalent of 25.625. Now we will move to third example, in which we will have different base. The decimal number is 27.4, and we want equivalent of this number when base is 4. As we have base equal to 4, we have to divide the integer part 27 by 4, and we have to multiply the fraction part 0.4 by 4. So let's start. 27 is the integer part, and we will divide it by 4. Quotient is 6 and remainder is 3. We will again divide 6 by 4. Quotient is 1 and remainder is 2. We will divide this 1 by 4. Quotient is 0 and remainder is 1. We will start from bottom and go to top. So MSB is 1 and LSB is 3. So 1, 2, 3 is the integer part for the number in base 4. Now we will multiply 0.4, the fractional part, by 4 and we will have 1.6. We will take this one out and we are left with 0.6. We will again multiply it by 4 and the result is 2.4. We will take this 2 and we are left with 0.4 again, and multiplying it by 4 give us 1.6. 0.6 multiplied by 4 give us 2.4. So you can see we are getting the repeated numbers 1 2 1 2 1 2. So we'll stop to the fourth significant place, and hence the answer is 123.1212. This is the answer. So whenever there is a situation in which number is repeating, you have to stop. Now we will move to homework problem. The decimal number is 25.625. This is in decimal, and you have to find out equivalent when base is 4. This is the homework problem. Once you have your answer, post it in comment section.